Are you ready to inject more fun into your learning? Today, I'm joined by Luke from Maths Pathway, who's going to share a whole bunch of fun and creative ways that we can inject into our days with our kids, especially over holiday break. So let's just jump straight into this one.
So good afternoon, everyone. My name is Luke Stoley. I'm from Maths Pathway, and today we're going to talk a little bit about things that you can do over the holidays to help your students or your children maintain their maths knowledge and enthusiasm so that they can hit the ground running going into next year. So I guess one of the key themes that we're going to go with here and really indulging in this plant-based metaphor for this presentation. But the idea is that over the course of the holidays, we obviously don't want to take it too seriously. We don't want it to feel too formal. We're not going to be introducing new maths necessarily. We just really want to make sure that plant is well watered over the holidays, so it's still healthy as you approach the new year. So watering the plant, not planting a new one, is kind of the theme for this one. Uh, and we'll expand upon that or hopefully make more sense. So, as I said, we're not looking to teach necessarily new content or force feeding curriculum to our children. We really want to make sure that we can still achieve some positive things, though. We can strengthen their existing schemas of knowledge. So that's how they organize information in their brains. We can help them connect what they do know to real life applications. And we can still build their confidence and help them to build that identity as someone who is very capable with maths and gets a lot out of it. So there are some things that we can achieve. And if we happen to, learn some new content along the way, that's a bonus, but it's not the focus over a holiday program. So what we're going to go through today is a little bit about brain science first, and then we're going to look at some specific activities that you can use. And then I'll share with you a little bit about some resources that Maths Pathway can help you with over the holidays and going into next year too. So in terms of the brain science, there are a few main considerations. One of them, and we can go into great detail, but I'll just keep it fairly light and brief. But cognitive load theory is one of the really important things that is influencing education at the moment. And basically, it's a fairly intuitive idea that we don't want to overload someone with too much information in one go. Once we do reach those limits, it's really difficult to make sense of things and to integrate that into your existing understanding. So we can't just give too much information at once. I guess the way that we might think of this is if someone was giving you directions to go somewhere that you've never been before, if they said, okay, you're going to go down Smith Street, you'd be like, okay, I can get that. And then you're going to turn right at Johnson Street. And then you'd be like, okay, I can remember that. But then if they start saying, and then they're going to go left at Prince Street, right at Princess Street, and then you're starting to lose that pretty quickly. So once we get to sort of that 4 or 5 directions, you've got virtually no chance of remembering it all, and it all becomes overwhelming. So the idea here is that we want to just have real clarity around what we want to introduce and keep it quite concise and brief. The other key concept is that obviously information decays over time as well. Our memories fade. And this is a really important thing because obviously with our brains, we don't want to have infinite knowledge stored in there because a lot of it wouldn't be relevant. So things that aren't used often or aren't deemed as relevant by the brain will fade over time. With maths, though, all the stuff that we are learning is really important. So we want to make sure that it doesn't decay over time. And so that's where having a form of spaced retrieval practice is the most effective way of retaining information over time. And so that's what we want to accomplish over the holidays, is making sure that the information that they'd previously acquired through the schooling year is regularly accessed and therefore it's not lost. And so the last thing that I'll say on this sort of brain science of this view is that in terms of that cognitive load theory, what is really important is your prior knowledge. That has a great influence on how much information that's presented to you can be accessed. So if you have very sophisticated, well-organized prior knowledge in maths, then when someone introduces a new idea to you, it's quite easy to sort of integrate that into your existing knowledge. If you don't have sophisticated structures in place, then it all just seems a bit random and chaos. Then it's harder to do that, or if it's just limited in terms of how much knowledge there is. So that's what we can try and help students to make sense of things, and the type of questions that we ask them can help really prompt them to organize information in more efficient ways, and therefore make new information next year more accessible. So that's another thing that we'll try and accomplish. One of the ways that we'll do this is by helping them understand that maths is all around us. And sometimes it's almost like the air that we breathe. it's just so pervasive that it's hard to even notice at times. But we have this system in our brain called the reticular activating system, where which is our filtering system. So once you notice something, you start to see it everywhere. So if you've been looking to buy a car and you've bought a red car or, let's say a red Ford or whatever it is, and then once you've bought that, then suddenly you'll start noticing them everywhere on the streets. Your brain will start picking it out. And so that's the other thing that we want to try and accomplish, is to help students make that connection between some of these maths concepts that can seem abstract at times and give them a real world grounding. And that's going to provide lots of those opportunities for that ongoing that spaced exposure that's going to prevent that decay over time as well. So in terms of reticular activating system, what we want to do is help them notice when these events do occur in real life so that they can use them and notice them more often. All right. That's enough of the kind of new brain science, but I guess some things that we're going to be wary of and weeding out these misconceptions is the idea that when a child is learning a new maths concept, the big challenge that they have is they often overgeneralize. They think that if this works in this one situation, it'll work in all situations, and that's probably where students go most wrong with maths. So we want to keep students aware of the fact that there are limits to what they're learning. There's always boundaries. So one of the examples of that is a student who might think that whenever I see an ascending order of numbers, then that means that the thing that I'm looking at is growing in size. So when you think about 1, 2, 3, 4, 5, yes, that's true. But if we turn that into a fraction where it's 1 over 1, 2, 3, 4, 5, and that's kind of the denominator is changing each time, that actually is becoming smaller over time. So if they overgeneralize to think that the bigger the number, the bigger the object, that wouldn't be true in that situation. So that's just something to be aware of, overgeneralizing when we're learning new things. And I think the important thing that you play an important role as a parent and educator is the emotional association students have with learning, and specifically with learning maths. It's it's one of those subjects that when you have a positive experience, it can be really, take you in one direction, but if you have one negative experience, it can really undermine your ability to want to learn or engage in that whole process forevermore. So for the plant sort of thing, we want to make sure you're preventing those kind of hazards from impacting it. And so we'll talk about the kind of emotional setup that we can have around learning as well. So yes, we're going to nourish, we're not going to force things. That's really the theme, is we're going to, it's a holiday period. We don't want students to be feeling like this is a never-ending school year. This is a chance to bit of a relax. So the first strategy, so what we're going to talk about is what you can actually do with that kind of general idea, is open-ended maths. So there's an opportunity to take something that might be fairly limited or a more formal procedural way of learning maths and just turn it into one simple open-ended question, and that can really make a difference to how it's perceived. As we start to think about this maths, when we're introducing an idea, I just want to come to this point first. So the first thing I wanted to talk about was the conditions for growth. So whenever we're about to learn some new maths, and if we had more people in attendance now, we could do some maths together. But generally, I try to encourage or try and foster curiosity, courage, and kindness. So curiosity, whenever a student has an opportunity to think about why we're doing this, or what if this happened, or is that always true? I wonder what else that relates to. All those kind of things are great questions we love students to ask. If curiosity is driving them, that's going to really drive persistence and engagement and intrinsic motivation. So that kind of curiosity-led learning is really important. Part of being curious is also being courageous, because when you don't know the answers, you risk making mistakes or finding errors, and how you perceive that is really going to make a difference. So being courageous to make an error, to try something, guess and check, is a really legitimate strategy of learning. And so fostering that courage to attempt those things is something we definitely want to do. And then obviously being kind on yourself. So when you do make errors or, prove something that's not true is another way of thinking about an error. To be kind on yourself, that this is not a reflection of you as someone who's not a good learner or you're not intelligent. We are actually very capable people. So curiosity, courage, and kindness are the three dispositions that we really want to try and foster as part of this as well. And then whenever I start a new maths task with people, I always think about these two rules first. Is really nothing that you do with this specific activity is a reflection of your general intelligence. We're going to keep it in a box, whether you do well or whether you do poorly with it, or it makes sense quickly or it takes a lot longer. That's not a reflection of you as a human, and with your general intelligence, it is. simply an activity that we're doing in isolation here. The other part of it is I am not the answer key, you are. So when we're encouraging students to engage in this more curiosity-led learning, we really want them to figure things out on their own as much as they can. They'll often seek an adult or an educator to kind of validate their views, and that's not really necessary. One of the good things about maths is that it is something that you can prove something right or wrong, and that's the really exciting thing about it is when you learn something new, you can think about, well, is that right? And how would I know that that's right is a great process for students to undertake. And again, we can take that general concept and look at it more
Yeah.
in a concrete way in a moment. Right. So an example. So when I mentioned before that if you gave a student a list of like, I want you to do these 20 questions, and you might be like, what's 4 plus 6, what's 7 plus 3, what's 8 plus 2, it might feel a bit monotonous for a student and it might feel formal. And that's kind of the vibe that we're trying to get away from over this holiday period. So instead of that, you could replace that kind of series of individual questions with one overarching question that will drive a whole lot of thinking that would have happened anyway. So instead of saying calculate 4 by 6, for example, you could say how many rectangles have a perimeter of 24 centimeters? What are the different kind of dimensions that they might have? That one question will provoke a lot of thinking for students. You obviously start to think about what would be the different lengths or widths that could be found. What would be the longest rectangle that you could have that would have a perimeter of 24 centimeters, or what would be the widest one? There's lots of sort of follow-up questions and opportunities for students to pursue curiosity as a result of one single opening question like that. Is that something that so Kylie, is that something that you've seen before or used with students before?
I haven't used this particular example. No, not at
No.
all. No.
Yeah, great. And so it does reinforce a lot of just that addition and subtraction and those kind of skills, but it's also the mathematical thinking, like how do I go about solving this problem? And then obviously we're integrating that into area and measurement too, so and perimeter. So
Yeah.
it does hit on a lot of different parts of maths with one simple question. So that's an example of the type of thing that we could do. In terms of the resources that I will share with everyone later on, I'll give you an example of one of those now. So a similar type of thing is how many squares could you find in the image below? So in here, you've got examples of a 1 by 1 square, and that's probably where people's mind would go to first. So I can see that there's 4 squares across the top, four squares across this column. And so that's going to lead 16 would be the number of squares. And so that would be someone's first thought potentially. A second thought might think about, well, hang on, what if I think about just the whole outside of it? That's a square as well, isn't it? So maybe I can see 17 squares. And then it's nice that you can talk these sorts of things through because then you can you might hear another perspective. Well, what if we thought about 2 by 2s as well? How many 2 by 2 squares are within this grid? And if we saw that there were 3 potentially across the top row, and then 3 across, then that would be 9. And then you could think about 3 by 3s as well. And you can see that there would be 4 of those. And so suddenly you're looking at 16 plus 9 plus 4 plus 1. And now we've got a completely different answer to what we thought at the beginning. And then you might even start to think about what if we looked at if this was just an array of dots as opposed to a lined graph, then we could start to look at it from a diagonal perspective as well. And then there would be even more squares to find if we were just thinking about it in a dot array. So one simple question can really open up, and we can have one simple closed answer of how many squares are there. And technically, there's no wrong answer. If you say how many squares can you find in the image below, well, whatever you find is the correct answer, isn't it? But there are obviously a lot of different potential correct answers there, which is a nice way of running an open-ended exercise. The good thing about these sort of things is that you can really explore them and go, this could be a simple 5-10 minute activity, or I could start to ask them to be more formal with writing these things up, and I could start drawing up a table and recording what I found. So I could have a table that said like 4 by 4 on one side, and then that means that there's 16 squares, and 3 by 3, and that there's 9. And so that recording a table is a really good mathematical process for students to follow in their problem solving. Again, that's an important part of addressing the curriculum too. Once from that, you might look at those numbers and say, what do you notice and what do you wonder? those two simple questions can really provoke a lot of mathematical thinking, and they might know something about square numbers that, hang on, 4 is a square number, 9 is a square number, 16 is a square number. Uh, that's an interesting thing to observe. You might even start thinking about algebraic ways of, what would be a formula? What if it was how could I find a number of squares in a 4 by 4 grid or a 5 by 5 grid or a 6 by 6 grid? And are there any patterns that I can observe as part of that? So it really is one simple prompt that can be explored in great depth if you've got the kind of student who really does engage in these sorts of things and does indulge in their curiosity and does have that kindness for themselves when they discover, I guess, limitations of their thinking. This could turn into an hour or 2 hours worth of maths just from one simple prompt.
Yeah. I like how you could print different variations of this and leave them around the house, especially in holiday time. So it's just that more subtle, let's do this activity together kind of thing. So yeah, I like that one.
Yeah, and it could really quite start in a really unintimidating,
Mm,
simple way by having like a 3 by 3 grid that becomes quite manageable. And then once people have had some success and said, "Yeah, I feel like I've solved that," it's like, well, what if it was 4 by 4, or what if it was 5 by 5? And then once they figure that stuff out, and if they're really showing some enthusiasm, then you can say, well, what if it was 50 by 50? How could you figure that out? And obviously, you get to a number that's too big to just manually do, and that would be the goal. The goal would be to use a more sophisticated strategy to find it that way. So that would be one idea, is to swap worksheets for open tasks. Benefits of this approach is that it helps you build the reasoning. And so when we talked before about that schema, that organization of your knowledge, these kind of activities really do build that out well. And then it makes it less likely for that knowledge to decay over time. So yeah, you get to explain the why. They can have multiple different strategies to achieve the same sorts of solutions, which is a good thing to discuss as well. And it encourages them to self-check. And so, is that true? That whole idea of I'm not the answer key, you can figure that out for yourself, and you can verify things. And that's the cool thing about maths, is that it's self-evident once you've sort of found the correct or incorrect. The next one I wanted to show you is this a gamified approach to doing things. And so there are different games that we could play. One example might be something like 1-2 nim. And the idea of this game here is that if you had, say, 10 counters to begin with, there's 10, me and my opponent could take turns selecting either 1 or 2 of those counters at a time. And with the goal being that you're the person who takes the last counter, or the goal could be the other person has to take the last counter. That either way is fine. But then you basically, so if I took the first one and I say I'm just going to take one, then my opponent is to take 2, and then I was to take another one, and then they were to take another 2, and then I took 2, and then they could either choose 1 or 2, and again, one person's going to end up with that last counter and therefore be the winner of the game. And it's a really simple little game to start to figure out some mathematical thinking. Uh, it There is a clear strategy that can enable you to become a reliable winner. And so you can have a conversation around what that strategy might be. And then again, you can start to think about variations of that game over time to keep it interesting. Like you could, rather than 10 counters, what if it was 15 counters, for example? What if instead of 1, 2, or only 1 or 2, what if you could get 3? What impact does that have on the game? And you can start to have a playful, gamified experience as you're engaging in some real mathematical thinking.
I love the simplicity of that one. Love that we
Yeah.
can be in the park and pick up some rocks and we can play that.
Yeah,
So yeah.
exactly. That's a kind of anytime, anywhere type of
Yep.
game. Um, this middle game here is Prime Climb, which is something that would be a more formalized game that you can purchase. So Dan Finkel is a maths educator from America, and he's got his website Math for Love, and he sells a variety of different resources. But Prime Climb is one of the games on there that really helps promote a lot of multiplicative thinking, and as well as strategy. And it's a game that I've got at home, and I've played it with my wife and my mother-in-law. My daughter isn't old enough to play a game like this yet, but it's a fun game. If you're looking to buy something and play a more formal game, then that'd be something that you could have a look at. And then the final one that I wanted to share with you is just this one called the Dots game, and I'll show you a visual. And this is something that on Instagram, there's a nice real of someone playing this. But the idea here is that you've just got an array of dots on a sheet. So it could just be with pen and paper, or if you've got a little mini whiteboard, you could set it up that way as well. But each person has got a different colored pen or texter or pen, and you can basically roll dice, and that gives you a chance to draw that number of lines. And for every time that you can enclose a space, then you claim that one, and that's what they're doing there is drawing the symbol that represents that they won that one. And the goal of that game is to try and win as many of those as possible. There are different variations of this game that you can play a version where every time you don't have a dice and every time you're just allowed to draw one line. And it could be just done with grid paper as well, so that you're trying to create an actual square. But for this version here, you can create a triangle and you can use a dice to just make it a little bit more fun and make it a more of a chance-based game as well, which is always nice, that balance of chance and strategy. Have you seen a game like this before, Kylie?
I like the dice variation. The non-dice variation has been a staple in our home, especially
Yeah.
for airports and
Yeah.
long car trips. Yeah, we taught the kids that really, really young. Yeah, so that one's been a staple, but I've not seen it with the dice, so I like that. I like adding that in.
Yeah. Yeah, exactly. I think any good game has a good balance of strategy, but also chance, and then the importance of your choices and actions affect the choices and actions I'm going to take. There are consequences to it, and I think this one really meets all the hallmarks of
Yeah.
that very well. Um, Something like Super Tic-Tac-Toe is another variation of tic-tac-toe, which is the type of game that would take much, much longer to play. And I've played it. It's almost like playing chess. The idea of that being that rather than just having a 3x3 grid, you have 9 3x3 grids in order. And there's a whole set of rules around that. But just, yeah, look up Super Tic-Tac-Toe as well as another game. If you've got a lot of time to kill at the airport, a pen and paper would do that very well. But yeah, there are some examples of some simple games that you can play as well. So again, making it feel light, but really these games have some serious merit to them mathematically too. Yes, so that gamification fun acts like sunlight. It provides the energy and motivation needed for growth. Yeah, so when we're thinking mathematically, curiosity grows naturally, fear of failure evaporates. So there's an expectation that you're going to have some good moments and some learning moments, and you'll get to learn from your opponent as much as what you will about your own thinking too. So yeah, there's some real benefits to gamifying it. I prefer games that aren't necessarily time bound and put that kind of pressure on. Like these games that we've highlighted here give you time to think, and people will have different kind of processing speeds. So that makes it a bit more accessible for everyone. Some people like time. Like again, it all depends on the personality. Some individuals really resonate well with trying to, achieve something within a time and then break a record, that kind of stuff. But as a general rule, it's potentially something that could put some people off. And then finally, I won't go into too many specific examples, but I mentioned before about trying to integrate this into the real world as much as possible. There are so many opportunities. I mean, obviously, over the holiday period, there's often a lot of travel associated with that, whether it's in a car or a plane or whatever else. But you can start to think about, how much time that's taking, what distance you're covering, what speed you're going at, those kind of things, as well as the geometry of maps, like what direction we're heading into, left and right. I think that's an important skill to maintain in these times where Google Maps and other navigation tools can really tell you where to go all the time, and you don't have to think about these things necessarily. So making sure that they are, regular opportunities to think about and talk about those sorts of things. Obviously, there's a lot of shopping lists going on at this time of year, so thinking about budgets, think about, obviously when things go on sale, are they a real sale or not? It's almost an important thing as well now. But yeah, what kind of discounting, all that kind of stuff. There's lots of percentages and numbers and fractions associated with that. A lot of cooking at this time of year as well. So getting them involved in cooking and recipes, all that kind of stuff. And then other kind of, there's a lot of sport events going on. If you're a cricket fan like me, there's infinite number of stats to wade your way through, as well as some crazy weather if you're living in Brisbane at the moment and you've just experienced then yeah, that's something to be mindful of too as an opportunity. So whenever we can make those connections to the real world, as I said, it'll take that kind of abstract experience of maths and turn it into something that you can experience on a daily basis, and therefore it's going to stay fresh in your mind uh, as we go. So though this that task that I shared earlier on, this one, that's part of a whole set. So there's some thinking prompts to go on the back of it. You can basically print off these as cards, but there's different activities that you're welcome to use, like so, that we'll happily share with you. So with that on, you can either use the QR code here, I'll get my cursor out of the way, or you can use this URL. If you type that in, you'll be able to access that set of resources. And yeah, feel free to do them as you please. It's going to provide you with the opportunity for little sips of water along the way. So, obviously plants, we can't just water them once with 200 liters and then lead them to it. We've got to give them little sips of water on an ongoing basis. So that's what those tasks are kind of designed to do. Unfortunately, this image is not loaded. But what I also wanted to just quickly mention is just that there's an opportunity as well for people who are looking for more rigor in terms of how they're delivering and supporting a maths curriculum to their children. Maths Pathway at Home is something that you can have a look at. There is really a streamlined learning experience for people. So they'll set a diagnostic at the outset. They'll find out what they do and don't know, and then get access to the maths that's right for them. And then it's something that they can work through really independently in a supported way. With warm-ups, there's videos, there's a whole set of questions where they get immediate feedback on they go, and then they get that confidence that they gain from answering questions correctly and achieving some growth over time. So that's something that you're welcome to look into moving forward as well. Pretty much it. That's all I really wanted to cover today.
That's good. Thank you very much for sharing. I like that you included some of the brain science in the beginning. I think
Yeah,
that's always important. One, to remind us, and two, for any of us who may not be fully aware of all that. So thank you for including that. Appreciate it.
no worries. My pleasure. Yeah, I think if you've got that in mind, it sort of helps you to know that why someone might be looking at you with a confused look on their face. Like I've probably gone too fast too soon, or I've given you too many prompts. How can I simplify it and bring it back and reduce stress and yeah, promote that positive mindset around learning new maths as well.
No, that's perfect. Well, thank you for your
Uh,
time. Appreciate
no
you.
worries, my pleasure. I hope that helps.